Alright, assuming you've paused your video, let's take a look at these two solutions. These should be rather straightforward because you'll realize that for this problem, 73 inches is one standard deviation above the mean and 67 inches is one standard deviation below the mean, which means 68% of American males are between 67 inches and 73 inches tall by the empirical rule, but rather we like to use that 68, 95, 99.7 rule because that's for cool people. Also, it's much more descriptive, right? Because what does empirical rule mean? Like, The Empire Strikes Back, is that a Star Wars reference? No one really knows. Now for the next problem, that's plus or minus 3 standard deviations. 79 inches is 3 standard deviations above the mean. 61 inches is 3 standard deviations below the mean. So that's 99.7% by the empirical rule. So now I want you to take a look at two more problems, and that's the point of this video. These last two problems. What percentage of Americans are between 75 inches and 80 inches tall, and what percentage of Americans are taller than 78 inches? And I want you to think about what's different about C and D in comparison to A and B. So pause your video and think about that. And because you're all super geniuses from the future, you all realize that 80 inches is not a perfect 3 standard deviations above the mean, but it's a little bit bigger. And that 75 inches is not a perfect 1 standard deviation above the mean either. So we are not allowed to use the empirical rule anymore. Instead, what we need to use is our handy dandy z-table. Ooh. You should have one of these already. If you don't, then you need to see me and get one. It's also in your book, this thing that you have. Woo, stats in your world. Let's see. This is, if you go to the back, I'm going to the back of the book, looking for answers, questions. Ah, wait, is that a z distribution? No, that's chi-squared. What's that? No, that's a t distribution. And then lo and behold, in Appendix G, Table A-59, you see this beautiful z-table. So there are no excuses, ladies and gentlemen. You should always have access to a z-table either by a handout or by the back of your textbook. Hooah! So, how can we use a z-table to solve this problem? Well, first of all, let's figure out how to use a z-table in general. So let's take a look at this problem. We want to know the probability that we're on a normal distribution and z is less than 1.3. So remember that z is x minus the mean over standard deviation. So what we're saying here is, what is the probability that I am less than 1.3 standard deviations above the mean? So if you draw a distribution, it looks like that. Let's look at our table. Now let's compare and contrast the probability distribution here with what we see here. Notice how the z-score is on the left side. So we flip the table over. Those look better. Now our z-score is on the right. So you look at your table, and we're looking for 1.3. So there's 1.3, 0, because the 100th digit is a 0. If we changed this to probability that z is less than 1.35, then instead of looking there, we would go over 1.31, 1.32, 1.33, 1.34, 1.35. Do you see it? Do you see the beauty? There's the 1.3. Yay! And then there's the 0.05. Yay! Giving us 0.9115. And the probability that z is less than 1.3 is 0.9032, 0.9115. So those are really simple z-score problems. This is a little bit different though, the problems we're looking at here, because, well, first of all, we're not given z-scores, we're given x's. So we're going to need to do a little bit more work. Let's get at it. We're going to take a look at C and D. And let's use this format to find normal probabilities. First of all, we need to draw a picture. Then we're going to turn the picture into less thans because that's what the z-table describes. Notice all of these probabilities are to the left. Then we need to make the x values into z values using a conversion. And then we're going to use our z-table. So, first step, draw a picture. So, we know it's normally distributed, and we've got these two scenarios. We're looking for what percentage of male Americans are between 75 inches and 80 inches tall. So, let's draw that distribution for C and D. Why don't you pause your video and try to draw this out? Okay, assuming you've paused your video, we draw the normal distribution. Always mark where the center is. And I like to do it with a dashed line. I don't know if you can see that dashed line right there. That's 70, because that's our average height. And then we are looking for heights between 75 inches and 80 inches. So we're going to draw there for 75 and there for 80 and shade in between because we're looking for the probability in between. For D, it has the same center. That's 70 inches. And we're looking for taller than 78. So there's 78 inches, and we're looking for that probability. See how that's nice and pretty and shaded in? Now, this part over here on the left, it's just between there. There's no shading to the right of that 70, or right of that 80. Okay? If you have any questions about these videos as we're going through, feel free to pause it and ask a friend or ask me. Next thing, once these pictures are drawn, take the problem, throw it away. We'll come back to it at the end. As long as we remember what the question's asking, we should be good. Now we need to turn the picture into less thans, and this is what's a little bit crazy. So, what we're doing is saying, with this first one, let's take a look at the 80. So there's 80, shade the probability to the left. Now we're going to subtract off 75. So if you take all the area to the left of 85, or left of 80 in this original problem, you've overcounted this whole area to the left of 75. So that's why we take that and then subtract off that. So if we write this as a probability statement, what this is the probability that we're between 75 and 80. So 75 less than x less than 80. That is probability of x less than 80 minus the probability that x is less than 75. Okay. For the other one, let's think about this. We've got two distributions. The first one is everything. And now we need to subtract off what we've overcounted. So if we take out the entire area here, notice that it's shaded to the right of 78. Think of the entire area of that, that equals 1. So that probability is 1. Here, now we subtract off everything to the left of 78 inches. Notice how everything in step 2 is shading to the left. So what this is saying is the probability that x is greater than 78, that equals 1 minus the probability that x is less than 78. And this should ring ideas of the complement rule. Because less than 78 and greater than 78 add up to 1. Now what we're going to do is make the x values into z values. So what we're going to do is find the first z value for 80. So z is 80 minus the average, which was 70, over 3. That's 10 divided by 3, which is 3.33. I think 2 decimal places works here. The second z value is 75 minus 70 over 3, which is, that would be 5 over 3, which is 1.67. Just to keep that in mind, that when we're saying this value, that's the z value that corresponds. Now same deal over here. Z is 78 minus the average 70 over 3, which is 8/3. That is 2.67. So, almost done, ladies and gentlemen. What we're going to do is take these probabilities and rewrite them as z values and then use the z table. So, here's how the work should look. First of all, we write the first probability statement. So that is equal to the probability that x is less than 80 minus the probability that x is less than 75, which is the probability that z is less than 3.33 minus the probability that z is less than 1.67. So we look at the z table for 3.33. So 3.3 is here, and 3 is over there. That's 0.9967. So you look at the z's on the left, 3.3, 3. Now remember, this body is all probabilities, and then the fringes are the z values. So that is 0.9996 minus, now we need to look for 1.67. There's 1.6, and then we go to the right until we get to 7. That's 0.9525. And that equals, let's see, 6 minus 5 is 1, 9 minus 2 is 7, 9 minus 5 is 4, that's 0. So that's approximately 4.71%. For this problem, let's take a look. That is the probability that x is greater than 78. That equals 1 minus the probability that x is less than 78. That's 1 minus the probability that z is less than 2.67, which is 1 minus, then go to the z table, look for 2.67. Let's see, I think I lost my spot. That's 0.9962. And that is going to be 0.0038. So that is 0.38%. So let's take that back to our original problems that we threw away earlier, and now we can answer them. So using these numbers, for C, we're going to say 4.71% of American males are between 75 inches and 80 inches tall. Here, we're going to say 0.38% of American males are taller than 78 inches. I hope you've found this video enlightening. I'm sorry it's a little long, but I think it provides all the information you need to use z-tables. going to do one more short video